Hey everyone, and welcome. Today we're going to tackle one of the biggest and coolest ideas in all of science, matter.
Okay, so let's start with a really big question. Look around you right now. What's your desk made of? What about the water in your glass, or even the air you're breathing? Believe it or not, the answer is the same for all of them, and that's exactly what we're going to dig into.
So here's our plan. We're going to cover what matter actually is, the three main forms you see it in, how it can change from one form to another, and the secret world of tiny particles that makes it all happen. Then we'll wrap up by looking at why things get bigger and smaller. All right, let's get right to it. First up, what exactly do we mean when we talk about matter?
It's pretty simple, actually. Matter is just, well, it's the stuff that everything is made of. I mean, everything, from giant blazing stars way out in space to the smallest speck of dust on your floor. If it takes up space, you're looking at matter.
Okay, so you see matter all around you, but it doesn't always look the same, right? Scientists call these different forms states. Let's check out the three big ones you deal with every single day. First up, we have solids. This one's easy. Solids are things that hold their own shape and don't really change their size. You know, like a brick, or your phone, or a book. They have their own shape and they stick to it. Next, things get a little flowier. We've got liquids. Unlike solids, liquids don't have a shape of their own. They take the shape of whatever you pour them into. Think about pouring water from a bottle into a cup. It changes shape completely to fit the cup. And last but not least, we have gases. Now these guys are the real free spirits. They have no fixed shape and no fixed volume. A gas will just spread out and expand to fill every single nook and cranny of whatever container it's in. The air in a balloon is a perfect example. So here's a super simple way to remember it all. Solids, fixed shape, fixed volume. Done. Liquids, no fixed shape, but a fixed volume. And gases, total chaos. No fixed shape, no fixed volume. They just go everywhere. But here's where it gets really interesting. Matter isn't stuck being a solid, a liquid, or a gas forever. It can actually change states. You've seen this happen a million times. You take an ice cube out of the freezer, it melts into a puddle of water. And if you leave that puddle on a hot day, it eventually disappears. So what's going on? It's the same stuff, water, just changing its form from solid ice to liquid water to a gas called steam. So how does it happen? The secret ingredient is energy, specifically heat. When you add heat, a solid melts into a liquid, so ice becomes water. Add even more heat, and that liquid will boil or evaporate, turning into a gas. That's your water turning into steam. And the cool part? It works in reverse. If you take the heat away, in other words, if you cool things down, it all goes backwards. A gas will condense back into a liquid. You see this when your hot shower makes the mirror foggy. And if you cool that liquid down enough, it'll freeze, turning right back into a solid.
Now for water, there's a kind of magic number for this freezing and melting stuff. It all happens right at 0 degrees Celsius. That's the exact point where ice melts into water and water freezes into ice.
And there's another magic number for when it turns into a gas. If you heat water all the way up to 100 degrees Celsius, it starts to boil. All those bubbles you see in a pot of boiling water, that's the liquid water turning into steam, a gas.
Okay, so we know what happens. We add heat, things melt and boil. We take heat away, they condense and freeze. But we haven't gotten to the biggest question of all.
Yeah, why? Why does a solid hold its shape, but a gas just spreads out everywhere? To understand that, we have to shrink down and look at a world that's completely invisible to our eyes. And here it is. This is the big secret that explains everything. It's called the particle model. The idea is that all matter, everything, is made of incredibly tiny little particles that are always moving. And whether something is a solid, a liquid, or a gas just depends on how those particles are acting. Think of it like this. In a solid, the particles are packed together super tight, like they're sitting in assigned seats in a classroom. They can't go anywhere, so they just kind of vibrate in place. In a liquid, the particles are still close, but they can get up and slide past each other. It's like the students can walk around the classroom. And in a gas, it's like recess. The particles are far apart, and they're just flying around freely and bouncing off everything.
Okay, so now that we know about these tiny moving particles, we can explain something else that's really cool.
You've probably heard that things expand or get bigger when they get hot, like a metal railway track in the summer. So here's the question for you. Does that mean that tiny little particles that make up the metal are actually getting bigger?
What do you think? The answer is absolutely not. The particles themselves don't change size one bit, not at all.
So if the particles aren't getting bigger, what is happening? Well, remember what happens when you add heat? You give the particles more energy. With more energy, they start to vibrate and move around like crazy. And as they're bouncing around, they push each other further apart. So it's not the particles that get bigger, it's the space between the particles that increases. And that's what makes the whole thing expand.
Which brings us to one last kind of mind-bending idea to think about. If all the particles that make up everything are always moving, even the particles in the most solid rock or in the chair you're sitting on are constantly vibrating, does that mean anything in the entire universe is ever truly standing still? Something to think about.